Okay, Brad, I finally got rid of the last Dell 24. It's either an 08 or 05 monitor in my house.
I'm less concerned about the 05 or the 08 and more about the 24. You had the 24 inch?
Yeah, so we got the 24s. We all bought 24s. I don't remember why. I think that we could buy them through the IT department at our company.
Aha.
And
That
got a little bit of a deal. Yeah.
Okay. We all bought the 20-inch version of that. We're talking that mid 2000s Dell monitor that literally everybody bought.
I think the 2405 was specifically the 05 model, and the 2408 was specifically the 08 model.
That's correct. We all bought the 20-inch because even a 20-inch was pretty expensive for an LCD monitor at that time. But anyway,
I thought it was like $500. But anyway, yeah.
I think it was $600 for the 20-inch, if I remember.
They've been aging in my garage for a long time now.
Oh.
And when my daughter wanted a computer during the pandemic, rather than buy a monitor, which was kind of difficult to get as everybody's setting up their home offices, I just went out into the garage and grabbed the one that had the display port and plugged it into her small form factor.
You went into your monitor cellar, grabbed one off the rack. They've been aging. You have some fine aged monitors here. This is a nice 2005 vintage.
Let's see. I have a 3008 in there that's dead, that has some sort of bad capacitor that I should probably try to bring back to life.
Wait, how many Dell monitors do you have?
Well, there's 4 maybe.
Hang on. I took all that grief for having 2 Dell monitors from the era, and all this time you had like 3.
Yeah, but the difference is mine are just not in e-waste, and yours you actually were using.
Mm-hmm. True. Yes.
But yeah. So anyway, Santa brought her a new 24-inch 1080p 144 hertz gaming monitor.
Okay. Not bad.
It's the zero bezel white frame. She was very the white was the important part, it turned out.
I can say, man, I didn't know. I mean, I'm not surprised they make white monitors, but I guess I have never seen one. Do they make other colors?
Mostly white. I think some people make pink ones, probably, if I had to guess. But,
ooh.
It has so little frame, it doesn't matter. And since I put it on an arm, then you can't see the base, which was white. So it's kind of ridiculous that it's white. But
well, now you just need a white monitor arm.
I mean, I could turn the black one white with a few minutes and some spray paint.
Yeah, fair. Yes.
What's the worst that happens? But the thing about it was she wasn't excited about it. Like, she wasn't excited about a monitor upgrade.
Hang on. Was it a bigger monitor or was it the same size?
It's the same size. It's the same resolution. It's thinner and faster. It's 60 hertz to,
Yeah, that's something the high refresh is something you can't appreciate until you see it, to be fair.
Yeah, but when she sat down in front of it, she's like, oh yeah, this is better. I like this.
Speaking of desk upgrades, I got a new plant.
Ooh, what's its name?
Around the holidays. I don't know if it has a name yet. It was actually not a new plant. We have a lot of plants in this house, by the way.
You do.
This was a hand-me-down from a different room. My girlfriend has an extremely green thumb.
Okay. Just like a cutting? Is this a child of? Or
no, it was a full potted.
Okay.
It's a ZZ plant.
What is it's ZZ?
ZZ, have you never heard of ZZ? Stands for it stands for something.
Oh, it's like ZZ Top? Does it have a beard?
Let's see. Zanzibar Gem is one name. Zamioculcas is another name for it, I think. Got a lot of Z's in it.
Look, I was down at the dispensary the other day. I got some Zanzibar Gem is all I'm saying.
Yeah,
you know what I mean?
I hear you. Zamioculcas zamiifolia is the actual name of this plant. Apparently, it's a thrives in low light plant, which was the key because there is low light in this office.
It's funny. One of the projects that I've had on my list for years and haven't gotten around to is I would love to make the wall off to the one that's off camera, the one's off to the side. I would love to just put a bazillion low light plants on there.
Yeah. I love a wall garden.
Yeah. Cause like this room is stuffy. The windows are never open because it has to stay dark for lighting. And because I like the dark, and I would love to have something living in here that's not me.
Yeah. And
whatever food I drop on the ground.
Yeah. I can't say that the number of plants in here is affecting the oxygen content of our apartment, but I can't say that it's not.
Look, it takes a lot of plants to affect the oxygen content of your apartment, and just one person to bring it down.
Well, hey, look, there are other benefits. Sometimes you sit in a largely lightless room all day. Sometimes it's nice to just stare at something green.
welcome to Brad and Will Made a Tech Pod. I'm Will.
I'm Brad.
Brad, it's the most wonderful time of year.
What, new video card time?
New video card season.
I have to confess, I'm having a little bit of a hard time talking about new video cards right now. I'm on such pins and needles over the intermittent issues with my audio setup here.
Oh, no. No.
Now I'm blowing up the all of my editing around the problems by just talking about it. I keep fuzzing out. You know, maybe we should leave one in the show and people listening who know audio can be like, oh, that's that kind of interference.
You just put it in at the end. Drop it in all the way at the end and let people get in there, because it's kind of hurty if you have your headphones on, is what I would say. So
what I'm talking about is since I got this channel strip and I've got a fairly complex analog audio mic situation going on here, and I'm just picking up some weird interference every so often. Largely when we record this podcast, it doesn't happen in like 3 weeks, and then this morning it's been happening again pretty badly, and it makes it hard to record when you just randomly fuzz out like crazy.
It's not even like a fuzz out. It's like
it's kind of scratchy.
Yeah, it sounds like you're playing an audio tape that has some schmutz on the tape, and it's messing with the reed heads. You got stuff on your reed heads?
No schmutz, please.
No schmutz. Well, while you've been dealing with your audio issues, I have been in video card testing times. Nvidia, you and I talked on a PC World live stream a couple of weeks ago during CES about the Nvidia keynote. We talked over the Nvidia keynote.
True.
Where they announced these, but I've had hardware since Monday, so about 5 days now.
Oh.
Only the 5090. They only sent me a 5090.
Yeah, they're being kind of weirdly cagey, or maybe not weirdly, but they're being kind of cagey about the 5080, right? Like, it seems like that one might be the least impressive relatively by price of all of them.
I mean, they always do a staggered rollout on these just so they don't have four. They announced 4 cards: a 5090, a 5080, a 5070 Ti, and a 5070. They're making Founders Editions for all of those except for the 5070 Ti.
Wait, really?
So, yeah, I think
it seems like 5070 Ti might be the price to performance winner.
I think that's probably the concession to the add-in board vendors, is that they're not going to compete with them on the one that's going to be the sweet spot.
That's the one everybody's going to want. So we're going to throw you a bone because we make all our money from data centers. Like, hey, that would
be my guess.
We'll let you sell all of the ones that people actually want.
Yeah, but so it's the first consumer pass on their new architecture. Blackwell has been out for a while now for data center users and for like heavy industrial compute users. But this is the first upgrade from Lovelace, from Ada on the consumer side. So 4090s came out 2 years ago, a little bit under 2 years ago, I guess now.
Yes, that sounds right. I think that's right.
Yeah. And then the other cards in that family followed. And that's the way this is going to roll out. So the embargo for the 5090s was Thursday, and the cards are going to be available on the 30th, I think, in, I'm going to guess, extremely limited quantities. But the other cards are going to follow shortly thereafter. And like, I'm sure people are already testing 5080s and so on down the line.
Yeah. Will the quantities be that limited? I mean, I'm sure there will be somewhat, but like, I mean, we're not in the like early pandemic, like everybody's fighting to get a 3080 type territory. You know, like the PS5 Pro came out and there were just plenty to go around a couple months ago. Like, feels like things are better.
I think it's going to be a demand situation more than a supply situation.
That seems crazy to me based on the relative performance increase of these things compared to the price and the heat and everything, but go on.
So the reason I say that is it's on the same process node, TSMC process node, as the 4090, right? So there's no new fab technology here that's going to make these things hard to produce. And in fairness, the 4090 supply has dried up over the last couple of months. So that implies pretty strongly that they've shifted. You can infer when they shifted over from 4090 production to 5090 production.
And also, as I understand, or at least looking at the sort of block diagram, this is a big honking die. So they get fewer per wafer, I assume.
It's a big honkin' die. So I mean, I guess let's start by talking about the hardware and what they changed on the architecture, because there's some big stuff that's changed. The main thing is that it has just a whole buttload more compute across the board. The memory bandwidth is increased from the 4090 as well. It's almost a 2x. It's like 1.7 gigabytes per second versus 1 1,792 gigabytes a second versus 1,008 gigabytes a second. And they do that by using GDDR7 and a wider memory bus. Yeah, the memory bus jumps from 512 bits, from 384 bits to 512 bits on the 4090 to the 5080. The reason the memory bandwidth increase is important is twofold. One, for the GPU compute people, it's important. But for people who play video games, there's a direct correlation between the number of pixels you can render traditionally using raster pipelines and the memory bandwidth usually. I mean, that you can hit bottlenecks in other places, but for the most part, you're limited by when memory bandwidth goes up, frames go up. So they redesigned the ray tracing cores. So they are more efficient and faster and more capable. So that means you can do more rays on each frame than you could previously, which means less noise, less kind of artifacting, less other shenaniganry they have to do to make the ray fill in look good.
Does that mean if you're running a ray tracing game on a 5090, it is actually casting more rays than it would on a 4090?
Yeah, that's my understanding.
It's not just that you're getting more frames with the same number of rays cast.
Yeah, and the same thing on the lower end cards too. So the 4070, 4080, 5080, 5070 will do fewer. You're doing more work with fewer rays on the lower end cards. So there should be an IQ improvement.
Yeah, this is very in the weeds. Then we probably need to talk to a graphics engineer to know this. I wonder how much of that is automated. How much of that is in the drivers or the APIs, or do you have to manually tune performance for how many rays you cast based on hardware, or does that just scale automatically based on like I said, is that handled at the like the library level?
I wonder if it's a choice. I wonder if you make the choice that you want to have X number of rays, and then if it. I actually don't know how that works. That's a good question.
Yeah. Although honestly, the denoising has gotten good enough that is it actually obviously it's better to have real data sampled than interpolated data, but it's still, I don't know if that's a huge advantage, because even the old cards look quite good with the current denoising and ray reconstruction and so forth.
Well, I was going to say, yeah, the ray reconstruction, which uses AI to basically fake more rays, it turns out is quite good. And is that and the denoising make the it's the ray tracing is fine on even like lower end cards that don't do that these days. Right. We've gotten better at ray tracing.
Right. Like even, we're really in the weeds here, but even on like a launch 3080 that I had, I didn't really have complaints about like the image quality of the ray tracing. I mean, obviously it's great for it to get better over time, but that was pretty good even from the jump, I thought.
Well, the big difference is that you can do you can do more complicated ray tracing games. Like if you look at the lighting model in Indiana Jones, right? They've done a full. It's the closest we have to a full ray tracing implementation.
Oh, even more so than Cyberpunk,
since they added path tracing to Cyberpunk. Like those are the two high bars as far as I can tell. In terms of what's being used, what makes the card do the work, and what looks good. So
I've got to fire up Indiana Jones. I've got a 4090, which is not the fancy new hotness, but still, I need to see that. I need to see that path tracing implementation.
It is. I'm going to go and tell you, it's nice to have a game that is both gorgeous and fun to experience the stuff with.
Sure.
I've been blown away with it.
Is that a stealth diss on Cyberpunk?
I find Cyberpunk to be almost incomprehensible.
Yeah, there's a lot going on there, sure.
Yeah. Okay, so 4 SKUs, 5090, it's $2,000, 32 gigs of RAM, huge memory bandwidth increase over last gen and the 5080. The 5080 is $1,000, it's 16 gigs of RAM. The 5070 Ti is $750 and it's 16 gigs of RAM. And the 5070 vanilla is $550 and 12 gigs of RAM. So I don't have any experience hands-on with the 5070, 5070 Ti, or 5080. But looking at the memory configurations, I assume that you're looking at 5070 and 5070 Ti as 1440p cards.
Sure.
And 5080 as a 4K card, and 5090 for people who buy the fastest card or do GPU compute stuff.
Yeah.
The memory bandwidth on the 5080, just so you have a point of comparison, it's double. It's half of what the 5090 is. So it's 1792 gigabytes per second on the 5090 and 960 gigabytes on the 5080. And then it goes down further from there to the 5070 Ti and the 5070. at 896 and 672 respectively.
Well, I mean, I started to say the 5080 doesn't look like a great deal, but also 5080 is half the price of the 5090 and also half the memory bandwidth. So I guess that, and I think it's like roughly half the compute units as well, right? So I guess it is actually that the price does scale to the capabilities pretty directly.
Yeah, I think like my guess is that when we get testing and benchmarks on the 5080s, which I think is I don't know if I'm allowed to say when the embargo is up, but like I don't have any firsthand knowledge of this. I haven't been involved in the testing on that card at all because I've been working on DLSS stuff since the 5090 reviews were done. It seems like, especially if you play at 4K, it seems like it's going to be a sweet spot for $1,000. It seems like they were aware of the problems with the 4080, which they kind of underperformed for the price last gen. And I am optimistic about this, but like I said, I don't have any inside knowledge, and I'll find out when everybody else does.
All right.
The big thing for the 5080 and 5090 though is the new cooler. So 4090s, if you spent some time with 4090s, for the most part, they started as big honkin' cards and went up from there.
Mine is a Zotac, my 4090.
Yeah.
And to be fair, I pulled the stock fan shroud off and got to put a custom one on so I could put Noctua fans on that thing.
Oh my God.
So it would be extremely silent. The fans that shipped with that thing sounded like terrible.
Yeah. It's a loud boy.
And now it's completely silent. Anyway, like the point is I made my card slightly bigger than it already was, but it was already very big. Like the launch 4090s were gigantic. Yeah.
The Founders Edition was a three slot card that was also very, very long and didn't fit in a lot of cases. The new 5090, 5080 design is a 2-slot. They call it a double blow through. Previously on the 4090, they did a cutout. They did a diagonal cutout out of the end of the board so that the second fan would blow through and you'd get straight through airflow. The thing that they realized is that when the air has to turn from the intake to the exhaust on the card, like it blows in and hits a radiator and then has to turn 90 degrees and go out either the back of the case or out the front of the card, that it reduces efficiency dramatically. So by doing these cutouts, they were able to increase the performance of the cooler. And on the 55 series, they went from having one cutout to just having the board floating in the middle of the card, with some daughter boards that go to the exterior monitor connectors and the PCI Express slot. And then the rest of it is just cooling. So it's huge radiators. There's a vapor chamber over the die and the RAM. And then there's heat pipes that carry the evaporated liquid from the vapor chamber, the gas, the vapor into the cool areas, cools them down, and then wicks the liquid back into the center so it can evaporate again.
That sounds complex. I saw, I wish I could remember who this was on Blue Sky that was talking specifically about the daughter board or one of the daughter boards, because if you're going to separate the functionality of something that's moving this much data this fast into multiple boards, then I think they have to be incredibly electrically sound, right? And they were talking about like the nature of the build of the daughter board and the interconnect between it and the main board is like, from an electrical standpoint, is like wildly impressive because they kind of have to be.
Yeah, because like you think about like making a PCI Express lane away from the motherboard is something we've been doing for years now with vertical GPU mounts, right? So you basically plug a card in, and then you have this big, giant, wide, firm, stiff cable that goes into a female PCI Express slot. Then you plug that into the bottom of your video card, and it just kind of hangs there, right? The thing that they have going from the PCI Express mount on the back of the main board of this card to the daughter card is like a tiny, I don't actually think they showed pictures of it, but the connector is very small. It's like a ZIF connector. And the fact that they have the whole thing running there is I think is pretty impressive. Getting the connectors for the displays less so, I would say, because that's, that's pretty, those are solved problems.
Those are just frames at that point. That's not that much data. The real question though is like, how well does this actually cool? I feel like I've seen mixed results from the initial testing.
It runs a little hotter than a 4090 typically under load, right? When I was doing testing of like Indiana Jones, stuff like that, I was seeing 63-ish. The Nvidia card was reporting 63 Celsius temperatures, which is, not, it's hot for a 4090. It's not hot for a 3080 or a 30 or a 2080.
Like that's well within spec, right?
Yeah. And versus 57C for the 4090 at the same kind of load.
Okay, that's not a huge disparity.
It is not. Now, the thing I will say is when I play a game that uses full ray tracing at 4K, it generates a lot of heat. Like you can tell it's actually working. I mostly play at 1080p because my gaming monitor is a 1080p 360 monitor. But I did have to change the airflow in my case a little bit. So my top back. So the way the air works on this is the fans are on the bottom. If you're in a tower, the fans are facing down. The fans push air up through the radiators, and then it comes out the top. There's a little bit of a Steve over at Gamers Nexus did a good video illustrating this with his weird camera setup that shows air turbulence, and it has two holes that come out of the top of the card that angle the air at like a 35-degree angle up, so that it separates the hot air on the top from the cool air on the bottom of the case. And as a result, you want more exhaust on the top than you probably have right now, especially if you have like fans blowing air in on the top. You might want to actually flip some of those around. I just turned up the exhaust fan a fair amount, and that seemed to do the job. But like, if you're playing games at 4K on this thing, especially the 2-slot designs, I think you're going to want to pay attention to cooling more than you have in the past, especially with the 4090, which just to be clear, 4090 had one blow through and then one that exhausted, which, did good work. So I think the board design's pretty nifty. Like I don't think the 2-slot design matters for gamers as much. I think it actually is a kind of a selling point for the AIB, not aftermarket, but the cards made by people that aren't Nvidia, because they'll have bigger, more traditional coolers that maybe run a little hotter or maybe run a little louder, but are more effective at exhausting heat from the system.
Yeah. And before we move on too far, I mean, we hinted at this earlier, but not to bury the lead. Like the GPU is way bigger. Because, like you said, it's on the same process. They have achieved better performance by making a bigger chip than last time, right? Like, we're not in an era of increasing efficiency leading to increased performance. Like, it is simply a bigger part, is a large part of how they're getting better performance, which is what has led to the higher power consumption and heat.
Yeah, that's not necessarily uncommon for GPUs, though. Often they'll stay on process sizes for longer than your typical CPU will, right?
Yeah, sure.
Because unlike CPUs, which you see a maximum upside to multi-threading, with GPUs adding wider buses, it just means more performance, and has since the dawn of time.
Right. But it is atypical for Nvidia, though, because going from the 20 to the 30 and then the 30 to the 40, there were pretty big efficiency increases in both those cases. So people have gotten a little used to each Nvidia generation bringing massive efficiency improvements, and that's not the case here.
Yeah, so they're both on TSMC 5 nanometer, and the 5090, the GB202, is 750 square millimeters, and the 4090, the AD102, is 609 square millimeters. So it's a little bit bigger. It's not a lot bigger, but it's not an insubstantial amount.
Yeah, that's like a 25% increase.
Yeah, that seems about right. I mean, the nice thing about them staying on the same process for this is it does make the possibility for a TI die shrunk version down to one of the other nodes that because TSMC 4 and some other ones, often on GPUs, they stay on the bigger nodes because they'd rather have supply than the heat matters less than having ready supply. So,
I guess all of that actually does kind of lead to the next big topic, which is all the AI stuff et cetera. Cause like that's kind of where they're seeing a lot of the big performance improvements and new features is in the machine learning based stuff, not in raw performance.
Well, so the raw performance, looking at the numbers, was, depending on the benchmark, was between 30 and 10 or 12%, up to 45 in some cases on some weird outliers where this happened to hit bottlenecks particularly well. Like Call of Duty I'm using PC World's benchmarks just because that's what I'm most familiar with. Saw like a 12% lift on Call of Duty, which feels low.
Or just that's just for straight raster increase, to be clear.
That was for straight raster increase. Yeah. So I guess the way to look at this is there's 3 different kind of categories of performance testing here, right? One is the straight raster, which is no ray tracing. It's just rendering frames with light maps and the way we've been doing stuff for 20 years. That's in recent generations. That's where we've seen the least lift. Generally, that's also often tied to memory bandwidth increase, which is why I think we see the lift that we do here. For ray tracing performance is usually gated by the number of rays, that like the speed at which you can generate the rays that are needed to render the scene. And in this case, pretty good. Numbers pretty good. The new ray tracing cores in Blackwell had significant performance improvements kind of across the board. I'm looking for my percent increase chart here. And yeah, like Cyberpunk with frame gen off saw a 30% lift from 5090 to 4090, which feels pretty good to me.
Yeah. I mean, I feel like ray tracing improvements are still somewhat academic. I mean, obviously people do play half trace games now, so it does matter, but like it's still, to me, that's still largely a gauge of, okay, how fast are we getting to the all ray tracing future, you know?
Well, and there's like 5 path trace, like there's not a ton of path traced games, right?
Yeah, that's what I mean. Like that's really the big question with ray tracing continues to be like, when do we see the first ray tracing like game that only ships with a ray traced renderer? I'm still guessing like maybe another 10 years from now.
It'll be either a PC exclusive title or it'll be next generation consoles.
That's the thing,
right?
It has to descend from the consoles having the grunt to also do that, because they're never going to do that just for a PC only game.
Yeah, that's exactly right. Like there are a handful of titles that have real modern lighting models available if you have the right hardware for it. Like Star Wars Outlaws, Black Myth Wukong, Indiana Jones. Like it's happening more.
Yeah.
For a long time, it was just Cyberpunk, and now we have other stuff coming, which is exciting.
And Cyberpunk the Cyberpunk implementation was like practically a research project in terms of the way Nvidia talked about it, but now it's just kind of showing up in games slowly here and there.
Yeah, I think that's a fair way to say it. Yeah. So like the uplift is pretty good on both raster and ray tracing. Like I would say more than acceptable for gen over gen, when you add in the multi-frame gen stuff that they've added with DLSS 4. So DLSS started out as like a machine learning augmented super sampling to take a low resolution frame and make it big.
Mm-hmm. Which works very well.
Yeah, it's great.
Like it's proven. It feels like proven technology. Like they've ironed out so many of the kinks that, depending on who you ask, I think some people would say that the machine learning upscaled frames are better than the raw frames at this point, or at least on par.
So when it works right, absolutely, I would say that's absolutely the case. I've been doing some direct comparisons between raw and different versions of DLSS, and more on that soon. I've not quite reached full conclusions yet, but it's a little messier than I expected when you dig into the frames. But the point is, these cards are running at 150 or 200 frames a second, and at that speed, you don't notice the mistakes.
Yeah.
Right. So DLSS used to mean upscaling. Now it's the name for the family of all of the kind of AI acceleration stuff. That started, it seems like, last generation, and I think I didn't clock it then, but yeah. So the DLSS super sampling, upscaling, the big thing is that they have added a new model. So previously it used a convolutional neural network, which they've kind of been around for a long time. They work by comparing adjacent pixels and saying, oh, if this pixel's black, then usually if this pixel's black and the pixel next to it is pink, then usually the next pixel is going to be blue, right? And they do that on a kind of very regional basis, which is why often if you had things that looked like hands, it would be like, oh yeah, this is flesh tone shadow, flesh tone shadow. That's exactly right. That's why we have 6 fingers on some of these frames sometimes, right? It's because it just keeps putting flesh tones and shadows and it doesn't know the difference. They've switched to a transformer model, which is what ChatGPT and a lot of the, I don't want to say smarter because that's not exactly right, but the more aware of context, it lets the model be more aware of context. So it knows if this is a screen full of dogs, there's likely to be other things that look like dogs, and it'll fill in things that it knows to be associated with dogs.
Right.
It's basically there's a bunch of terrible analogies for this, but the idea, with these, you're always just going through you're placing vectors through arrays, 2-dimensional arrays of whatever you're looking at, pixels, words, whatever. In this case, you're looking at, instead of going at a 2-dimensional array with the transformer, you're adding more dimensions. So you can kind of, it's aware that if there's a thing that's pink here and there's a thing that's black here on the other side of the screen, often the things on this will be this and this and this. And the upshot is you get fewer weird artifacts. There's still going to be artifacts, but they're novel and new in the same way that, like, when you change from one kind of video compression to another kind of video compression, there's still artifacts, but they're different and your brain doesn't pick them up as easily.
Right. So is transformer a generic kind of machine learning term of art then? Because Jensen dropped that in the reveal at CES for this. And I mean, it's not really the place for it on stage, but he didn't really do a great job of defining what a transformer is or means. But the point is, this is not some like new Nvidia innovation. This is something that exists in machine learning generally. Yeah,
this is something that came out of research like almost 10 years ago at this point.
Okay.
And yeah, the idea is more context to, like I said, the important thing to know in this case is for DLSS, the convolutional networks, neural nets, are aware of the pixels in the immediate area around each pixel that it's generating with the upsampling. With the transformer, it's more aware of the broad pictures across the entire image.
Right. And I think just to reiterate, in case it's gotten lost here, the convolutional neural net, the CNN, is the old way that DLSS did upscaling, and the transformer is essentially just the new way. I'm seeing here there's a performance difference.
There is a little bit of a performance difference. The transformer is more expensive. I've done benchmarks. I have benchmarks running on fully path traced Cyberpunk, running on the entire stack that runs DLSS for real, from the 2080 of the high end stack, rather, to the 20 series, 30 series, 40 series, and 50 series. And it seems to be between a 2 and 3%, maybe 4 at the absolute outside performance hit to run the transformer model.
Yeah.
It's in beta now, so it's only available on a couple of games for us as pre-release.
Okay, I was going to ask how you kind of opted in. If games are going to, surely games are not going to expose like different types of DLSS upscaling at some point. They'll just switch. I mean, that just seems like needless complexity for the average person to have to figure out what to set it to.
Yeah. So for us, there's a flag in Cyberpunk that you can switch between CNN and Transformer on the DLSS panel. I don't know if that's going to ship. I like you said, I hope not, because it's kind of confusing for normal people. There is a flag in the Nvidia app in the what used to be the kind of graphics settings pane for in the old Nvidia control panel, where you can flip it on for the games that support it. And right now it's available in Cyberpunk and Veilguard, Dragon Age Veilguard. I did my testing in Cyberpunk just because it has a benchmark loop and it's easy to get fairly repeatable results.
Just to make sure I understand, I mean, I think you said this, but so this new version of DLSS upscaling is available on basically every card that does DLSS, right? All the way back to the 20 series?
Yeah, it
That's
should.
Cool.
But I mean, with the beta drivers that they gave us for testing, yes. I don't know what the rollout's going to be. I assume that this is going to be available for everybody to try on the 30th but what the rollout, so they block the transformer model on games that don't actively support it in the driver panel.
That makes sense. Now. But the big point here, though, is this is definitely not a 50 series exclusive or even limited to like 40 and newer.
Yeah, there's actually hardly any of the stuff that we're going to talk about, except for the multi-frame gen, is limited to 50 series.
Right.
Almost everything is coming to the older cards. And yeah, it's like. The places that I noticed it working better are on things like chain link fences and transparency that the convolutional networks have traditionally had problems with. I'm going to say, having captured a bunch of footage and done frame by frame comparisons of 8 different ways of rendering this stuff, the effect's real subtle.
Oh, like, yeah,
There's an occasional glitch that you'll notice that jumps out at you, but for the most part, you have to like be resting your eyeballs on the screen and moving the mouse real fast to see most of this stuff.
Like you said earlier, at 120 hertz or more, it's kind of hard to pick out weird artifacts in individual frames or even a bundle of frames. So like, I'm not expecting, once this option rolls out everywhere, like, of course, for the tiny performance hit, I'll probably flip on the better version, but like, is it actually going to be noticeable in a profound way? Probably not.
I think actually, like to me, having spent I spent 2 days playing games with this stuff on and off and trying different ways, both qualitatively and analyzing and just experiencing. And for me, the metaphor, the analog is video compression, where when you move from MPEG 2 to H.264, like there's still compression artifacts in H.264, but they're different looking than the MPEG 2 ones. And it was a little jarring. Now, of course, when you go back and watch an MPEG 2 video from like the 90s, it looks real blocky and weird because there's block artifacts in those videos that we just our brains filtered out because we were so used to seeing them. Right. And I think this is going to be the same situation.
Yeah. I mean, this is a worthy goal, to be clear, even if the differences are not hugely noticeable, like in any situation where you're conjuring data from nothing, and you're extrapolating frames that don't exist from smaller ones that do. Accuracy is a worthy pursuit, right? Like they should always be striving to make this more accurate, even if the differences are very subtle.
Well, and the benefit of doing this is that you have less stuff going through the raster pipeline, which let's see, the way to put this is performance hiccups in the raster pipeline, which is where all of this stuff starts, have a negative downstream consequences on everything else in the pipeline. So, your brain is really, some people, we should start. There's a cognitive spectrum for people with regards to things like frame rate and micro stutter, and frame rate is the number of frames that are thrown on the screen every second. Micro stutter happens when 1 or 2 frames in a row take a lot more time, double or triple the time to render than the frames on either side of them. So it feels like you have a hitch. And in an extreme case, like I had a driver bug the other day when I was testing something, that I was getting 1,000 frames per second average frame rate, but I was also having my 1% low frames, the slowest frames, I were running at like the equivalent of 8 frames a second. And even though the vast majority, 94% of those frames were running at 1,000 frames per second, it felt like the game was running at 10 frames a second because the stutter on those hold frames, your brain perceived those at such a high level that the game felt really, really slow.
Right.
So a lot of the work that they do here is to reduce that micro stutter and to smooth out the frame rate and get the frame pacing really good. It's why my favorite example of this is when you play Doom, one of the new modern Doom games, 2016 or Eternal. And those games are fast, but they're not like, they run at like 90 frames a second, but they feel so much smoother and faster than most games. And it's because the team that works on those and the engine they use, they pay really attention. They pay a lot of attention to frame pacing. So the frames come at a really even rate. So your 90 frames a second, your minimum lows are also like 88 frames a second or something like that.
Yeah.
Typically on that game.
Yeah. Like modern id cannot get enough credit for how much they prioritize smoothness and presentation and efficiency in their tech.
Yeah, and it makes their games feel like they're coming from a different era. They're so fast.
They really, I mean, it feels like butter to play those games is the best way to put it.
So, okay, so which brings us to multi-frame gen. Frame gen is one of those things that Nvidia rolled out last generation, and they specifically said, hey, this is a way that we're going to help combat micro stutter, to give you some machine generated frames to fill in gaps when there's timing problems with your raster pipeline or your ray tracing pipeline, either one. Those timing gaps, like if you've played Star Wars Outlaws, apologies for picking on Massive, but that game has some crazy micro stutter problems in my experience. And like when you flip on frame gen in that game, it feels much, much better because their frame pacing is bad. And so last gen they rolled out one rastered frame, one ray traced frame, and then you take one generated frame traditionally, and then it would machine generate another one using the tensor cores on the GPU.
Like I hesitate to use these terms because there's a lot of what I'm about to say.
There's a lot of baggage.
Like there's a lot of the FUD. I don't know what the term is. There's a lot of Sturm und Drang out there about this
People
feature.
Have a lot of feelings about AI generated frames.
The term I hesitate to use, but it is descriptive, is I was going to say for every real frame, there's an AI frame. In the original single frame gen, situation. You get one real rendered frame and then one machine generated frame.
Yeah. So the big thing with this generation of cards is that they've done something that sounded crazy in the keynote. I think we both reacted about the same way, which is they went from one real frame generating one AI generated frame to having one real frame generating 3 additional AI frames.
Yep.
So I'm going to not bury the lead. Having spent a lot of time playing with this, it feels really freaking good.
Really?
When you flip it on.
Really?
Yeah. I was I was a little cool on the first gen fake frames.
Yes.
AI generated frames.
I'm not a fan.
Just because the latency increase is pretty substantial on most of them. The time when you move your mouse to when you feel that movement happen on screen felt mucky. With a controller, you notice it a little bit less because the controller doesn't do one-to-one input for the most part, and so you kind of your mushiness gets lost in the mushiness of the controller. With the mouse and keyboard, especially at a mid to high sensitivity, I noticed it immediately, and it felt like you had weight on your mouse input in a way that feels bad.
That's a good way to describe it. Yes.
The multi-frame gen on Outlaws makes Outlaws feel like Doom Eternal.
Wow. That's a pretty bold statement.
Yeah.
All right.
I mean, it feels playing with a mouse and keyboard. Just to be clear, I played Outlaws with frame gen on and a gamepad because the mouse input felt so swimmy and the micro stutter was annoying to the point that I didn't play it without that turned on.
Well, I mean, that's effectively a console game. Like I could see, controller is probably the ideal way to play that game, regardless of other factors.
Yeah.
I'm not in any way doubting what you're saying, but I am going to say I'm going to continue to be very skeptical of this feature until I try it for myself and come away feeling the same way you do because it sounds too good to be true. But go on.
100%. So the thing to know is that, and I think Digital Foundry said this first years ago with the first gen, is that this isn't tech that gets you from 20 frames a second to 40 frames a second or 80 frames a second. This is tech that gets you from 60 frames per second to the refresh rate of your 240 hertz monitor, right?
So you're saying you need a large sample size, a large pool of real frames for this to work right?
Just as DLSS, which gets better when you start with a 1080p or a 960 or 1200 horizontal resolution or vertical resolution rather image, and then scale that up so you have more data to start with. This works better when you have more frames to work with. When I tried it with a game that was running at 20, when I cranked everything up and ran it at a really high resolution to get the game to run at 20 frames per second natively and then turned on multi-frame gen, it felt swimmy and crappy, just like it did before.
Really? Even with the multi-frame? Because that was, I mean, when they first rolled this out, I'm trying to think, frame gen was on the 30 cards, right?
40 series
was
when frame gen was introduced. Yeah.
Anyway, that was the original problem though, was you were on hardware that, like with the path tracing in Cyberpunk, for example, barely could manage 20, 30, maybe 40 frames a second. So you were getting the swimminess because you had you had so little actual performance to work with.
So there's a couple of things that they changed this go round. As before, it requires Reflex to work. So the game has to support DLSS, multi-frame, frame gen, and Reflex. Reflex provides vectors. Reflex is a low latency technology. We'll talk more about it in a minute. It's designed on its face to reduce the time from motion of a mouse or an input device to the photons on the screen reflecting that movement that the mouse does. But as a side effect of how it works, it has to provide vectors for how the camera and objects in the game are moving to the video card driver. And multi-frame gen, frame gen use that vector data to generate the next round of frames. So it's not just looking at this picture and saying, oh, this picture, we're going to make this picture look like the next picture. It's saying, oh, okay, the input on the user and the input on the on-screen objects are moving in these directions. Here's what we can infer from that and rendering the next frame from that.
Yeah, it's a very educated guess. It's not just working off of an image and nothing else.
Yeah. So the other thing is that the multi-frame gen, the 5 series cards moved the frame pacing from the CPU to the hardware on the GPU now. So they have more control over when that happens. It's less likely to get bottlenecked, and it reduces the time from when the frame is generated to when it's displayed on the screen.
Okay.
They're also running all three of the frames are generated off of the one raster frame at the same time.
Oh.
And then, so they're not generating a frame and then generating the next frame off of the AI, first AI frame, and the third frame off of the second AI frame.
Oh, interesting.
So they generate one and then they warp the frame to match the input that you've done at the last second, right before it's rendered, basically.
Also through machine learning?
Also through machine learning, yeah.
It's just so abstract and hard to get your head around.
It's the way I think of it is it's kind of like anti-aliasing, which anti-aliasing would render some or all of the screen at a higher resolution and then shrink it down to reduce the jaggy aliasing on like diagonal stuff back in the day.
That's super sampling, right?
Well, that's super sampling is a type of anti-aliasing. So you render up and then you shrink it back down and it blurs the pixels together. So there are various types of anti-aliasing that will just focus on the parts of the screen that are tended that it picks up jaggies on. There's temporal AA, which blurs frame to frame so that, you know, it works forward in time, basically. But this is kind of like AA for time, in that it is just giving you additional frames for when the rendered frames come in hot or slow. And yeah, there's only a handful of games that it works with right now. Cyberpunk is one of them. Outlaws is one of them. I think Alan Wake does. It was one of the other games that they offered us to test. But I didn't. That was the thing I spent the least time with. The Outlaws change was pretty remarkable. Cyberpunk runs great. Just to be clear, I don't know what the number is with all the path tracing on and no DLSS or no frame gen, but like Cyberpunk on a 5090 at 4K will run locked 30 dead solid with everything turned all the way up and no AI stuff.
Native 4K.
With
no assists. Okay.
Yeah, no assists. The multi-frame gen, I expect it to still be controversial. Some people in the first round of reviews didn't even test it, which I get, like, you know, whatever, do your thing. I feel like it's pretty, like, we've gone from a point, to me, this feels like the DLSS 2 moment. You know, DLSS 1 was trained per game on to do the upsampling. So you had to, you know, they had to train a different model for each game, basically. DLSS 2 was when they rolled out the generalized model. And that felt like a moment when DLSS suddenly became a viable tool. This feels like the moment when the frame gen stuff becomes worth turning on. Okay. To me.
All right. I will approach with cautious optimism, but I definitely still need to be convinced firsthand.
I think the hard part of this is you have to play it to understand it. Yeah. Like we can't, if we were on YouTube, we couldn't show you a video that's going to make you understand why this is good.
Yeah.
It's purely a difference in feel.
Yep.
And like I said, you're not going to go from 20 frames a second to 80 frames a second. You're going to go from 60 or 80 frames a second to 240 frames a second.
Yeah. Or 144.
My big question is, how is this going to work on the cards that are less performant at the lower end? Because, you know, Jensen came out on the stage and was like, hey, your 4070 is going to be as fast, your 5070 is going to be as fast as a 4090, which is true from a certain point of view. If you have on the 75 titles that will support DLSS 4 right out of the gate.
Yeah. And world's biggest asterisk there, because who knows how that'll feel if those cards are turning out fewer native frames, then you may get the swimminess that makes that not super worth using.
That's it. That's exactly it.
Real quick before we move on, just a quick addendum to something I mentioned earlier. Apparently, Digital Foundry did an interview at CES with Brian Catanzaro.
Yeah, it's a fantastic video if you haven't watched it.
VP of Applied Deep Learning Research. Anyway, he hinted that frame generation might come to the 30 cards at some point.
All the way back to the 30 cards?
They're not committing to it, but well, actually, I mean, the actual quote from Catanzaro is maybe a little more general here. They asked him about getting frame generation working on previous cards. I think this is primarily a question of optimization and also engineering, and then the ultimate user experience. So we're launching this frame generation, the best multi-frame generation technology with 50 series, and we'll see what we're able to squeeze out of older hardware in the future. So
that to me says maybe multi-frame will come to the 40 series.
That is exactly my conclusion from reading the actual quote here. Maybe frame generation on 30 is a bit more of a stretch based on that quote, but but they aren't ruling out some improvements on old hardware in the future.
Look, I am a fan of this work. I am excited to see if it comes to the older hardware. I was pleasantly surprised by the transformer model running on the older tensor cores. Like it ran fine on the 2080. Now, was it getting a playable frame rate in path traced Cyberpunk on a 2080? No.
Yeah.
But the performance drop for turning on transformer model was the same pretty much across the board. Well, let's see what else we got. Reflex 2. Reflex 2 is not available to test right now, so I don't know anything about Reflex 2.
What?
Yeah. It's only in the finals in Valorant.
I'm sorry. I thought the whole pitch was that Reflex 2 was a big part of how they were making multi-frame gen palatable.
That is fascinating that you say that, because I thought the exact same thing from the keynote, but it is they might be using frame warp for the MFG stuff for those last frames. That was the part that I think was confusing to people.
Okay.
Which is also being used in Reflex 2. Again, Reflex is the, hey, reduce the time it takes to move your mouse. Typically, especially for players that play at medium or high sensitivity and high frame rate, like the render position of the game is typically one frame or more behind where the mouse actually is for the person controlling it. Generally speaking, people who are really good at first person shooters, like professional players who train, drill to learn how to like bypass this effect.
Oh, wow.
So like they'll move the mouse and then stop a frame early. But the whole point of Reflex is that you don't have to necessarily feel those hitches. So Reflex 2 is adding frame warp, which is basically they take the frame that they get from the rendering pipeline. This is all with frame generation, all that stuff off, because you don't want frame generation on competitive games at all. So the way the Reflex 2 works is they've got a low latency frame generator or infill generator, basically. So they warp the camera position based on the vectors they get from Reflex at the last possible second, and then paint in any stuff that doesn't render with the AI.
Seems so ridiculous. I think I've said this before. When I just visualize this process mentally, like it seems so seat of the pants, absolute last second. You know, the fact that you're literally distorting the frame and then having to paint around the edges that you no longer have just to get the frame out is like it just seems so crazy in concept. But I guess, you know, clearly they have made it work. Yeah.
So, I mean, like I said, I haven't seen it running. I haven't. The folks who did see it running, I think DF did a video about it at CS because they had the finals demo running there, Digital Foundry. I'm wildly curious to play this. It's only coming to the finals in Valorant at first, available for 50 series GPUs. They're saying 75 to 50% faster, lower latency than Reflex 1 with boost to the high speed Reflex 1. So I'm interested to see that. That means that your latency will be down to, I think they said 2 milliseconds in Valorant.
Wow.
Which is like, at that point, they're good. They don't have to worry about this anymore.
That's a solved problem at that point. Is Reflex 2 coming to every card?
Starting with the 50 series, but it seems like it's coming to the older cards later.
Okay.
Yeah.
Okay.
My guess is that the low latency fill in, they have to do optimization to get working on the older cards.
Yeah. Yeah. You know, I mean, I guess the good news, I mean, if even if the entirety of Reflex 2 is not required to make multi-frame gen work, eventually, once both of those things are fully supported in games, they will work in concert together to hopefully make multi-frame gen better.
So I actually, the multi-frame gen, I don't know if you're ever going to want to turn on competitive games.
Oh yeah, definitely. Absolutely.
Because you don't want to add latency and you don't want to add, you want real frames, ground truth as close as you can get. Right.
But, but you know, most people are not making their living playing first person shooters. So we'll see.
So I did a little bit of informal testing where I had my daughter come in and flip multi-frame or frame gen on in COD for me a week or so ago. And she would flip it on and off without me knowing which one it was. And then I would play a handful of games on a game that I have a pretty level KD ratio on a game type and level that I have a straight like 2.0 usually. And I would drop to 1.5 to 1.6 when frame gen was on.
It's
pretty consistently.
The old Coke and Pepsi blind taste test.
Yeah. Except for the Pepsi thing only worked because they only let you take one sip, and everybody likes Pepsi when it's one sip. It turns out because it's real sweet.
Harsh, man.
Look, Pepsi sucks. That's the official policy of this podcast, Brad. I'm sorry.
Harsh.
You get your lightning plug. I get Pepsi sucks.
All right.
Worth mentioning that the Reflex 2 stuff, it works in CPU bottleneck scenarios where Reflex 1 is not as effective.
Oh,
so
okay.
And then I think we've talked about this already. The stuff that works on the old cards versus what works on new cards, it's pretty much the same as before. Frame gen is 4 series. Multi-frame gen is 5 series. Everything else works on everything except for maybe Reflex 2, which seems like it'll start on 5 series and then roll out to the older cards over time.
Yeah.
So that's like,
good news for people who have old cards. Nice to see new features coming to this stuff, and particularly like 40 series where the performance increase on these is, noticeable but not profound. Like to get just about all of the new features on a 4D card is pretty good news.
Yeah, I think the classic, hey, buy every other generation if you're going to upgrade often, it remains safe, right?
Yeah,
because the 40 series will hold for through this 2 years if that's what you're worried about. And but I think this is if you are I always buy the new card, there's stuff here that's worth buying. The question to me is whether to buy an AIB third-party card with a more traditional cooler or go with the smaller, potentially hotter 2-slot. And unfortunately, the reviews for the add-in board coolers, that embargo dropped as we were recording this podcast. And they're all over the place, depending on also the price on the add-in board cards is all over the place as well, like up to $2,800 in some cases, it looks like. There's a couple of other things I want to hit real quick if we can. They demoed at the keynote some new features. Yeah. And this is a thing they often do. It's usually a mixture of stuff that's actually the future of computer rendering for games and then some hooey.
Seems like a good way to put it, because some of the stuff seems like it will become bedrock practice in the next 5 to 10 years. And some of it seems like no, thank you.
Yeah, the neural shaders is definitely hey, this is going to be bedrock in the future.
Absolutely. Of this list, that seems like the thing that okay, next year people are going to be using this to do interesting things. Yeah, so this uses AI modeling to basically it both provides a performance and a functionality increase by using AI what's the right way to say this? By generating materials in games using traditional methods and then kind of chunking that down into an AI shader. So if a material in a game, like any surface you look at in a game has a material attached to it, and that can have a whole bunch of stuff, a whole bunch of ideas attached to it. It can have the color of the texture. It can have the texture of the surface, whether it's bumpy or smooth or shiny or smoothness, opacity, translucency,
emissiveness.
Yeah. And even down to things like fur and kind of simulating more complex things on the surface.
Whether there's subsurface scattering, whether there's materials that appear through the translucency, like skin. If you look at your hand and you're in a bright light, you can see the veins and the dark spots where the bones are underneath. You can see the pores. You can see all this different stuff. And a lot of that happens because the light goes into the top layers of your skin, bounces around a little bit, and then comes back out. And so the benefit of neural shaders is, you can do that stuff with traditional shader model stuff, but it's really computationally and memory expensive. It costs a lot of memory. It costs a lot of computation. And what they're doing is they're applying machine learning to that space in a constrained way. So they're taking the models that are generated traditionally, and it's almost like it's not exactly compression because it's doing more than that, but it's like compressing the computation down by using machine learning, which is I think everybody who listens to this podcast know I'm pretty bearish on generalized generative machine learning stuff. This kind of stuff is really exciting to me because it's something that it's doing something that we can't do with traditional models.
Yeah. Or, this is another one of those examples of sort of programmatic use of machine learning, right?
Yeah.
They're not generating art necessarily with this. This is more of just kind of a different way of executing something they're already doing in a more efficient way.
They're taking art that's generated and making it express more efficiently.
Yeah. Or in this case, not just art, but code, right? Shaders are small programs at the end of the day.
Yeah, but also without changing the artist's intent is the other thing that's important here.
Right.
I talked to a couple of tech artist friends who work in this space and like are the people who build the materials for a lot of for games you've played. And generally they were pretty bullish about this. They were excited about this.
It seems interesting. And then in the Nvidia presentation at CES, they flat out were posting like VRAM requirements alongside these things. Like, hey, the old version of this takes 28 megabytes and the new one takes 17 or whatever. Like they're supposedly there are actual tangible memory saving benefits. I'm curious to see where this stuff goes. And I don't know how shaders would tie into like physically based rendering, because that's the sort of thing you need for ray tracing, because you need to define the physical properties of all of your materials and surfaces and blah, blah, blah. So I don't know if this helps there as well, but like anything that's getting us to a more generalized physical future of the rendering seems good.
Given what the hardware is capable of, my guess is if we want to have physicality based rendering on real-time stuff, aside from relatively limited examples like Teardown is a good example of a they do physicality based stuff, but it's all hard surfaces and it's not, there's no you're not going to make a physicality based renderer right now that looks like those Trolls movies, right? That's a good example of that.
Yeah. Well, we should distinguish here between like standard like rendering PBR is just a surface property thing, not like a physics thing necessarily.
But yeah, this is how we'll get there in real time is my assumption. And the word on the street is that Intel, AMD, Qualcomm, Microsoft, everybody's on board for this. So we've seen the Nvidia implementation, but my guess is that we'll, like, as we get into next gen consoles that have more tensor core, like AI compute capability, this is where we'll see that stuff start to roll out.
Like maybe I wonder if this even gets standardized in DirectX maybe at some point.
I would assume so at some point. Yeah. Neural textures, same kind of story. It's using machine learning to do deterministic texture compression at rates that are really ridiculously high.
Oh, interesting. I'm just looking in your notes here. Doesn't decompress into memory.
Yeah.
So it's kind of almost like being able to work with a compressed texture that you don't have to do, that stays compressed as you render it out.
Yeah, that's the exciting thing. And the 7:1 ratio for compression is the number that they threw out. That's over existing technology, texture compression technologies.
Yeah, that seems like big. I mean, does this work without noticeable artifacts? TBD, but that sounds promising.
Well, I mean, the first step is that it's deterministic, so that means it's the same every time.
Oh, sure.
The phase 2 is how does it actually look, and I haven't spent enough time with it to know that.
Yeah.
The mega geometry is the other thing that's cool. So one of the things that happens, a lot of objects in games have levels of detail. So they'll start with a hero version of your say table or tree or whatever, and then you also generate some kind of chunked down lower fidelity versions of those. And depending on the game, you can go up to like 7, 10, 20 of those sometimes. Those every time when you're doing traditional raster rendering, it doesn't matter. It just pops whatever one in, puts the light map on it. It looks right. When you're doing ray tracing, every time you change the level of detail, your ray tracing, your pixels for that object, your rays rather for that object have to be tossed, and you have to do that math again. So it's fairly expensive to change levels of detail in a ray tracing environment. The mega geometry is a solution for that uses tessellation and a bunch of other stuff to basically make your trees look good.
Yeah. Is this? I may be out over my skis here, but is this? I looked through some of their kind of developer press docs for this stuff. Like, is this somewhat analogous to, like, for example, UV5's nanites? Like virtualized geometry is kind of a thing now. Like, it's not just Unreal 5. I want to say there's one or two other engines as well. They're doing this kind of like abstracted geometry that gets rid of levels of detail, and just, the whole pitch with that thing was like, put your high level hero high geometry assets straight in the engine and it just looks the same all the time. Performance is handled, forget about it. We're doing it on the back end. But my understanding is that stuff was pretty CPU heavy before now. So
yeah.
is this I wonder, is this a GPU / maybe neural net based solution for that same thing? I don't know.
Well, so, I mean, these are similar solutions for the same problem, right? The difference is that this works on hardware ray tracing, and Lumen and Nanite are for Nanite is basically software ray tracing.
Right.
Lumen rather is software ray tracing.
Yeah. And then geometry tessellation and all that stuff.
Yeah. So it should be more performant. It doesn't run. Obviously, this is only these are all NVIDIA implementations for now. So this is in Alan Wake apparently.
Oh.
Like if you download the latest version of Alan Wake 2, you can see this in action in the forest scenes.
Yeah. As a side note, I have noticed most UE5 games spin the hell out of my CPU fan.
Yeah, UE5 games will spike your CPU pretty good.
Yeah,
it turns out. And then the last one is the neural faces, which is when we get into the. I mean, they talked about ACE, which is their character generation with real natural language stuff, all that.
There's like prompt based animation. What they were describing as like text to animation, where the screenshots are like artists typing.
Yeah,
like waves their arms around and then stretches really tall or whatever. Which we'll see.
That's the kind of stuff that like is real good for investors and game developers all kind of laugh at.
Yeah, and the neural faces are basically kind of like deep fakes for 3D character models. Is that?
Yeah, they basically take the face that's generated by the character and character artist, and then they use that to create an upscaled photorealistic version that they then deep fake onto the model basically in real time. And it looked real floaty and bad in the videos that I saw. The Digital Foundry guys saw a slightly newer rev of that. They talked about it in their post CES breakdown. When I talked to character artists about this is where the tech artists were excited about the neural shaders thing. The character artists were like, "Oh hell no, this is not okay. We're doing this because we want it to look a specific way." And if you look at something like Indiana Jones, where the character faces are generally very expressive, and they replace Harrison Ford's face in Indiana Jones with a deep faked version of Harrison Ford's face from Indiana Jones, that's like, it's going to look, this just has real smooth Yoda vibes to me.
Yeah, for sure. I mean, it gets back to the problem of determinism again, right? Because like a pattern on a quilt, exactly that's supposed to look the same every time, and you can massage the model until you're getting the pattern on the quilt that you want. Like the human's facial expressions are very not understandable by a computer, let's say. So like getting what you want every time out of that seems way trickier and maybe impossible.
Also, it's unnecessary, right? Like the point is you're gonna, like, if you're building a game, you're choosing and you're thoughtful about it, you're making a good game, you have made style choices and artistic choices based on the capability of your team and the size of your team and the size of your art staff, but also the game that you want to make. And if you take a game that has like a real defined style and then deep fake on some Gen AI faces, it's going to look like crap. And it's just like this again, a lot of times, a lot of the AI stuff and the places where the AI stuff has had the biggest gap between what people who make AI software think I want and what I actually want is when they're taking away artist intent and replacing it with a machine. And this is that. Like, this is, I was bummed to see this.
Yeah.
So anyway, that's the kind of, I want to hit one more thing that's kind of off of our two things. One is that these cards are high power. The min spec on the 5090 is 1,000 watt power supply.
Yikes,
min spec. It uses the 12 volt 2x6, which is the Rev 2.1 12 volt high power.
Like that's the 12V HPWR, to be clear.
Yeah,
that's the AT. The point is that's the ATX one, right? Like that's the one that you should have if you have an ATX 3.0 power supply.
Yeah, and it's physically compatible with the 12 volt high power. My 12 volt high power that was in my power supply had a 450 watts number written on the side of it.
Oh, interesting. Mine might have that as well, actually. I need to look.
So I had to upgrade. I mean, I had an 850 watt power supply, so I had to upgrade anyway.
Mine might be 600 actually.
But yeah,
I have a 1200 watt.
The 1200 watt supply had a 600 watt one.
Okay.
From our anecdote, I mean, like when we did power testing at PC World, we were seeing total. We didn't break out the power supply, the power draw from the PSU from the video card, just because that's fraught and you can't isolate the slot power and all the other things. We were seeing total system power that was significantly higher with this new card than the older cards. And I'm trying to find the numbers here, but
I think I talked to Adam briefly, and I think it was like over 700 watts total draw.
Yeah, that seems right. Cyberpunk average power consumption was 533 watts with spikes at like 702 watts.
Okay,
Again, this is for a
peaks then.
7950 X3D.
Yeah.
And a 64 gig system, I think.
Okay, maybe that's maybe an important clarification. Those were 700 watt peaks, not sustained.
Yeah, the average for the Cyberpunk run was 533 watts.
Okay.
That includes a little bit of idle on both ends as it's kind of ramping and loading and all that stuff.
All right, good to know.
The other thing is that the packaging, I want to shout this out because they don't have to do this, and it's like I think the 4090 packaging, especially for the Founders Edition, was kind of overkill and had a bunch of plastic and crap in it, and it made this great big cool presentation box for a thing that you're gonna probably most people are gonna recycle about 5 minutes after they put the card in their system. The 5090 box is all paper.
Okay.
It doesn't use any plastic fasteners even to seal the internal shipping material and all that. So it's all like it looks like a dog bone, and in the cutout sides, you slide these little loops in that slide into notches and they hold it closed. It doesn't have any plastic to throw away at all in there that I saw, except for maybe the adapters, which, you may or may not use.
Yeah.
And I just wanted to shout that. And it's a much smaller box than the 4090, which means they can ship more of them in a crate, which means less carbon. So that's good.
That's good. Like Sony made a very notable or profound move toward that kind of sustainable packaging, starting with the regular PS5. I don't think they did anything before that. But anyway, I got the PS5 Pro recently, and they literally use cardboard twist ties now.
Yeah.
Like obviously there's still a metal wire in the twist ties, but the outer covering is cardboard rather than or paper rather than plastic. Like everything in that box is biodegradable now, which is kind of nice to see.
Yeah, the whole box can go in the recycling bin, or I guess probably even the compost bin. I don't know what the ink situation is. But yeah, I was impressed, and
That's
it
nice.
was a nice change.
Yeah.
And there's no plastic shock material or anything like that. It's all just corrugated cardboard all the way down. So props to them.
Yeah.
And then we got to talk about my real problem with the 5090.
Go on.
Well, I've had 3 slot cards in my machine for a while now, Brad.
Okay.
And when I had to put this in, I couldn't remember where I put the slot cover for the 3rd slot, because this is a 2-slot card.
Wait, you
on the back of the
covers?
computer?
Oh, you mean like the bracket?
Yeah.
The bracket that covers the...
Yeah. So, it took me forever. It was a nightmare. It was awful.
That's probably a good problem to have.
I mean, it was okay. It was an okay problem to have. But yeah, it's weird having a 2-slot card in there again.
Yeah, I believe it. I also am ready for... I need a smaller GPU as well, because this roughly 4-slot card is making motherboard choice kind of difficult when you need to use the other PCI Express slots.
Yep.
I'm never or more general. I'm just ready for maybe a move to smaller graphics cards in general. Hopefully we'll get there. But anyway,
you should just stop playing games and
that
just
works.
get a passive.
Yeah.
Just use it. You can use integrated.
Just
get an AMD
in.
machine. You just use that built-in CPU, built-in GPU.
This Raptor Lake has got a fine iGPU in it. I'll just go back to that.
There you go.
That'll
done.
run Fortnite,
Perfect.
right?
Yeah.
No, probably not.
It'll run. I bet it'll run the Switch renderer.
Yeah.
You can switch to the Switch renderer if you're on.
You can?
Yeah.
On PC?
Uh-huh. They don't call it the Switch render. They call it performance mode, but it's
okay. It's
basically like a DX11 looks just like the Switch when you play it.
That's funny. I wish they did call it the Switch renderer, but I get why they don't. Anyway, new graphics cards.
Yeah. So if you have questions, this should have been a question week this week, but we will do questions next week as is our way. So if you have Qs, you can send them to techbot@content.town, and we will turn them to A's this time next week. I guess we've reached the part of the show where we thank our patrons.
We have. Thank you, patrons.
Thank you, patrons. As always, Brad and Will Made a Tech Pod is a listener-supported show. So without you, we would not be here, which means if you want to find out how to support the show, you can pay us $5. It's at patreon.com/techpod. For that $5, you get 2, well, I guess it depends how you count them. You get 2 things, but they both contain multitudes. One of the things is access to the TechPod Discord, which is full of beautiful nerds who talk about all sorts of fascinating stuff all day.
Mm-hmm. Yep.
I dip into different channels and I learn something pretty much every time.
It's a fount of wisdom in all respects. Let's say, okay, I should not even get into this. This is patron episode material.
Uh-oh.
Let's say you have become bent on self-signing all of your EFI binaries so you can turn on secure boot on all of your computers when you multi-boot a bunch of esoteric operating systems, and you need to know about that stuff.
Okay, I have questions, but I'm going to hold them for the Patreon episode. Did somebody know how to do that?
Oh yeah, you can do. You can literally open SSL your own. Okay, I caveat to what I'm saying here. My current understanding is this is possible. You can generate your own keys.
Yeah.
Sign all the EFI binaries, which are the things those are the boot, it's basically the bootloaders that launch your operating systems. You can sign all those yourself and then enroll your public keys into your UEFI as valid secure boot keys. And then you can secure boot basically anything as an EFI binary.
But then what happens if you just have to make sure you back up your keys before you update your BIOS?
I don't know yet. Well, I mean, worst case, you just turn secure boot back off and everything.
I'm going to tell you, fine. When I had this happen and I turned secure boot back off, Windows just never booted again. I had to reinstall Windows.
Yeah, I think that's changed now because I did turn it off the other day. I think now you have to have secure boot on to install 11, but then you can turn it off afterwards is the case.
You can have secure boot off. You just have to have a TPM 2 module.
Yes, I guess maybe that's the case actually.
Yeah. You don't. Secure boot's optional.
It's a whole rabbit hole. We'll get into it at some point.
Yeah. The other thing you get that contains multitudes is the Patreon episode where we talk about stuff like Brad's adventures with secure boot and self-signing certificates and Let's Encrypting, I guess. So to do that, you go to patreon.com/techpod. Again, it's patreon.com/techpod. And we appreciate the support from everybody. If you don't have $5 to do that, that's fine. Just leave a review someplace like iTunes or I don't know, Spotify does reviews now, or Deezer. Deezer has reviews. We love Deezer.
That's not a real platform.
Deezer is a real platform. We are on Deezer, right? You can go to Deezer.com and look for Brad and Will Made a Tech Pod, and we are there, Brad.
Whatever you say, man.
But we've reached the part of the show where we thank our patrons, starting since the end of the month with our executive producer tier patrons, including Andrew Slosky, Bunny Thing, David Allen, James Kamek, Jordan Lippett, Twinkle Twinkie, and Pantheon, makers of the HS3 high-speed 3D printer. Since it's the end of the month, we also thank our associate producer tier patrons, including Alejandro Navarro, Andre M. Burke, P.E. Or it's Andre M. Burke, P.E. I don't know what P.E. stands for. Andrew Dicey Scholdice, Arthur Gies, Ben Tallman, Brutal Kerfuffle, Eric Klein, Felix Kramer, Graham Banks, Jad Rita, Just Associate Wedge, Matt Walker, Walkman 8080, close parentheses, Mike Etheridge, Nathan Phelps, Sanchit Kumar, Steve Lynn, Thomas Shea, and Tom Hilton. Thanks everybody so much. We appreciate the support.
Yeah, we sure do.
And shout out to the people who put the phonetic pronunciation of their names in their names when it's tricky, because that really helps a lot.
Yeah, sounds like an example of some secretly encoded information, but we'll get into that.
Oh, secretly encoded information. If you have that, we have a form that you can submit ideas for secretly encoded information in, which I guess we can put in the show notes.
I will put that in the show notes.
Perfect. And Brad, this has been a pleasure. I guess we'll talk to you next week
yes, I hope
about questions. TechPod@contact.town. See you all next week. Consider the environment before printing this podcast. Bye, everybody.
Now you just got to get a white monitor arm.